So our second speaker of the evening, Maciej, is going to talk to us about deployment and various other interesting things. I'm really looking forward to this talk. You've got a big act to follow, no pressure.
Oh, this actually worked. This is the first time Linux just worked on the conference, so hello, hey there. First of all, thanks to nearForm for organizing, and thanks for Engineer for hosting this meetup. I'm Maciej Malecki. I talk to servers. If I'm lucky, they talk back. I guess I'm talking to you here, so I've been pretty lucky so far. First thing, let's go back to the talk title, right? So building architecture is the easier way. One thing I wanted to talk about first is that if anyone tells you that they found a silver bullet for deployment, don't trust them. Never ever trust them. And in fact, what I found out is that the only silver bullet that you can find in deployment is to stop looking for a silver bullet and just find what your requirements are, build your system, accept your limitations, and just roll with that. However, given the state of things, I still think that that we can do better with deployments. So anyway, how many of you are satisfied with your current deployment process? At your company, at your personal project, whatever?
No, not yet.
Yeah, okay, yeah, we can definitely do better, better than that. So the concepts I wanted to talk to you about today are my ideas for making deployment easier and less painful. So the concepts I wanted to talk about are immutable infrastructure, service registries, microservices, and monitor everything. The first concept, immutable infrastructures. How many of you have experienced that or worked with that concept? Okay, yes. Yeah, Peter. Yeah.
That's what I'm doing. Never read it.
Yeah, I'll explain that. So I'm willing to bet that all the people who've done their fair share of deployments here have seen that. So you code a thing, you're very happy that it's out. You tested it on your local machine. Maybe you even deploy it to staging. Who knows? Maybe you even have a staging environment. And then you deploy it to production. You install the stuff, and it fails. People are running around, screaming, waving their hands, running to fire exits, whatever. I mean, you don't really know what happened because you don't have time to check. You're very busy with bringing production back to the state it was in. And I mean, you bring it back, right? You install the older software, you do all the things, you do the rollback. But the damage is done, like your magical 5 nines of uptime are gone. Clients are sending angry emails and stuff like that. But anyway, what if I told you that there's an easier and a safer way? So imagine that. Imagine what happened if you could just take your newest deployment, your newest software version, deploy it to production, and then test it really calmly. Put some stress tests onto that. Maybe run your integration test suite, and just like test it out before just putting it into deployment. So this is actually possible thanks to the concept of immutable infrastructure and all the other concepts I want to introduce later today. So basically, what the concept is based on is never upgrade your servers, never ever upgrade your servers. So either a new version of your in-house software or new OpenSSL version or a new OpenSSL bug, I'm sorry, which means I guess you're going through a lot of servers especially if you deploy a new server every time an open SSL bug happens. So this might have seemed crazy back in the days where all we had were servers in the racks sitting in a data center somewhere. Because you're not going to reinstall your operating system every time you deploy a new version of software. However, these days we have stuff like DigitalOcean, AWS, or even if you want to host yourself, you have Docker and you have SmartOS and all the crazy hipster deployment stuff. But that still seems like a lot of work, right? You still need to whatever you use for load balancing, either DNS or your load balancer, you still need to edit IPs and add entries to DNS, whatever, depending on what you use. It still seems like a bunch of work, right? So there is actually a solution to that, which we call service registries. So simply put, a service registry is a service that registers all other services. So there are multiple examples of that, but the basic idea is that all your applications call out to the service registry and tell it, hey, this is where I am, this is my IP, this is my port. If anyone's interested in talking to me, come talk to me at this port, right? So it's really nothing fancy. I mean, you can make this happen with Redis, with whatever you want, but it's actually a bit more complicated than that. So, what makes a good service registry? A good service registry is distributed, first of all, because there is no real use for a service registry that goes down if the only machine hosting it goes down, right? So you really need something that is resistant to failures, resistant to stuff like network failures, which happen. I mean, if anyone tells me again that network failures don't happen, I will just punch them in the face right away. I haven't done that yet, so please don't get me to that. Consistent. So that means you don't really want to be talking to hosts which were hosting that version of software like 20 seconds ago, because 20 seconds ago is actually a pretty long time, and when it comes to computers, like it's millions. I'm pretty bad at math, so it's probably millions of CPU cycles or something. Expiring. So what that means is when your application hits up the service registry, the registration can only be valid for a couple of seconds, say, or even hundreds of milliseconds. So when the application goes down, the service registry doesn't receive things from that application anymore, and it thinks, this application hasn't talked to me in a bit. I'll better invalidate that. I'll be like, yeah, this one's gone. Don't talk to it, man. And easy to integrate. So the real power in service registries is that they integrate with all the other stuff in your infrastructure. So what you can integrate, for example, is a load balancer or DNS API. But I'll talk about that more in a second. So there's something wrong with that slide again. This is a subjective opinion. So your requirements for your deployment might be way different. They might be way off from my requirements. So again, this is really subjective. I mean, you might want your service registry to not be consistent and instead be available and partition tolerant, as per the CAP theorem. So again, it's all very subjective. So examples. When preparing for this talk, I found out one very interesting thing. There are tons of service registries out there, and I formed a suspicion that service registry might actually be the hello world of DevOps. It might be a thing that everyone writes, either one way or another, and they end up publishing that on GitHub, and people end up using that, what's even scarier. But anyway, here is, so what, I have a service registry going on, right? What do I use it for? So what you could use your registry for is, you could hook it up to load balancers like HA proxy. You'll notice the heart there. I love HA proxy because it's so flexible. HA proxy does stuff like TCP or HTTP, all sorts of really good stuff, and it's used in production a lot by companies like Facebook or CDNs or like stuff which you really heard about, or Nginx, AWS, Elastic Load Balancer. You could even hook it up to DNS as a service, so that say you have a website, and all the servers serving your website pick up the service registry, and the service registry integrates with the DNS, so it tells the DNS, hey, those are the IPs you should be hitting up. And if one of your website hosts goes down, then the service registry is like, yeah, don't talk to that anymore, remove that A record from there. So the examples of that are AWS Route 53 or 59, I think 53, DigitalOcean DNS API, and all sorts of services like that. If you want to get really fancy, you will also use your service registry to drive firewalls. So this is really fancy, and probably if you work at a bank or something, you'll do that. Sorry if you work at a bank. I'm only saying this because someone in the audience works in a bank. Anyway, you can also use it to drive CDN like Fastly. So let's say you have a host that serves your images, but of course you want it to be distributed and you want it to be really fast. So you spin up 10 instances of that, and each of those talks to a service registry and is like every 5 seconds, like, yeah, I'm here, and then the CDN can use them as its upstream host. So anyway, let me show you real quick a service registry I made back in the day while I was working for a startup in Amsterdam. I will just put that on the second screen, and it's gone. Oh yeah, here it is. So the registry is called Bender. It was mentioned in one of the previous slides. The Bender comes from Futurama, of course, and at that point when I was writing it, the tagline is basically "kill all humans," because I wanted my deployment to be completely automated at the time. This is, of course, a self-plug, but this is also the only registry I could get working in less than a day while I was making this talk. So here I start the HA proxy component. It registers itself with itself. So it says that, this is going to get useful in a second. So it says that I'm here. If anyone ever connects to this cluster, then they should hit up this particular service and start replicating from this service. And it's all based on the concept of CRDTs, which is, I use Dominic's star CRDT module, which provides, which basically provides eventually consistent replicated data store. So I started the second peer so that I have 2 peers in my cluster, and I tell it to connect to the first peer, which is listening there in the left window. And as you can see, the left service registry, I'm just going to say left, recognize that there's a second peer connecting to it, and it automatically connected to it as a peer. And here, this worked. Let's go to another screen here. And okay, and here I have a really simple example app I wrote to demonstrate how this works. So I start examples register, and what examples register is really just a really simple server that serves the very basic the Node hello world, except in HTML, and it also registers itself with Bender. So our service registry starts registering as soon as it listens on the port. So it says, hey, if you ever want hello world, then just hit me up here. So let's start one instance of that. Yeah. So as you can see, it registered with Bender. It picked a random port, 41145 in this case. And let's start a second instance of that, which is configured the exact same way. And it will also, it picked up the first registration, and the first registration picked up the second registration, because they are both connected to the same cluster. And so what we do now is Bender works on so Bender is actually very focused on HA proxy, and what HA proxy and the entities in the HA proxy system are frontend, backend, and server. So frontend is, say, a domain. Backend is a set of servers, basically, and server is, well, a server. So what we can do here is see if this actually registered. So this is going to pick up the default Bender host, which is just localhost. And you can see here that we have two Bender instances listening on API port, so a very basic HTTP API host, which the CLI uses to talk to it. And then the CRDT port, which is what Bender uses to exchange information with other vendors. And the really interesting stuff are two hello world applications. And what I'm going to do now is create a backend for that. So I'm just going to create a backend called HW, hello world, which creates that backend, and I'm going to create a frontend for it. So here I have a front end and a back end. Here I specified that the port the front end is supposed to listen on is 7000. But this is actually not something special. The port parameter isn't special at all, because the Bender HA proxy, what it does is it just fills out a template, which it then feeds to HA proxy. And you can see this is a really simple, what's going on here? Okay. It fills out a really simple template, which it then feeds to HA proxy as a config. And I can show you, so I put in 7000 as my port, right? So what I can do now is just curl 7000, and you see the hello world, right? And you see on the left, you've got the request. So all of this works. I didn't embarrass myself yet. So let's start benchmarking this, right? So I started WRK with some very basic parameters, and back to that. And we can see that both of our registers are getting requests, right? So this is working so far. But what happens if I introduce the third node? It started getting requests right away, right? So why that happened was it registered with Bender, and Bender noticed that the application is hello world, and that it's actually eligible for getting requests for that thing. Oh, my benchmark finished. Let's start again. Right, so we have that. So what happens if I kill this? Right, nothing really bad happens, and why this happens is that HA proxy first of all, HA proxy checks for its upstream host status, and the second thing is this registration, which that host had actually expired after a second or something like that. So it expired really quick, And I'm pretty sure that the benchmark tool won't even notice that. I'm pretty sure that HTTP will just retry the request to one of the other hosts. And yeah, here we have it. We only have 36 read errors, which is actually pretty good for the amount of requests it sent. Seeing how one of our backend hosts just went down really abruptly. So anyway, there's that. And oh yeah, here you can see how the vendor HTTP reloaded its config. So this is basically why you use service registries to enable you to really quickly deploy new versions of application and really quickly register them with whatever you have, be it load balancer or DNS or whatever. So now the next topic I wanted to talk about is microservices. So seeing how this meetup is held by nearForm, you probably heard about microservices tons of times. But anyway, the really short explanation is that microservice is a small thing you deploy to satisfy a concern that you have, right? So I heard this from lots of people that microservice is actually a service which has small amount of code. Which is like, well, yeah, it's kind of true, but if you're going for that, then well, you kind of fucked up. And so less code, of course, helps because less code means that there's less potential for bugs, right? The more code we write, the more bugs we have in this code. So this definitely helps. But also, what I found out that microservices help with a lot is that you have better testability because you just have one thing and you have one concern to fulfill, right? So you really easily unit test that. You can mock your database in that. Whereas with monolith complex applications, anyone worked with Rails, by the way? No, they burn at all. Yeah. So. I found that just trying to minimize the amount of things that service does really helps with testability and things like that. And also, there's less inclination if you do microservices. There's less inclination to go for a monolith stack. So there's less inclination to. I mean, this sounds good for some people. It doesn't sound good to me, but there's less inclination to formalize your thing. There's less inclination to write your own framework or something like that. So the most microservices I write is just a simple Node HTTP server, which just parses the JSON that's coming in, and it's like 10 routes at most. It's most likely 2 or 5 routes. So for me, this actually helps a lot with testability, and it just helps with maintaining the code. I mean, you will be writing a bit more sort of one-off code, but I think you will be also happier in general with how the code looks like, and you'll find yourself doing less changes to those particular repos. And I should also note that deploying microservices without a deployment framework or service registry is kind of painful, right? Because otherwise you have to fill the DNS records or hard-code IPs or something like that, right? And hard-coding IPs is pretty damn painful. So this is one thing that the service registries definitely make easier. Yeah, there we go. Okay, so next topic, which I mentioned is monitoring. So I wanted to show you, I've previously worked at a company which completely disregarded monitoring, and from my experience, here's what you know about your infrastructure without monitoring, and pretty much that. So the stuff I think you definitely need to monitor. And as far as this isn't a talk about monitoring, which you can totally do a complete talk about, but monitor every single thing. So monitor your CPU usage, monitor your network I/O, monitor your disk I/O, and the thing which I consider the most important is monitor your functionality. So hit up that endpoint which you have for user creation once in a while and check if it actually can create users. I mean, users and network bandwidth are really cheap. So you can do that in the live operation system. And if it breaks, then, well, it's your own default, pretty much. Monitor response times. Yep.
There are a lot of things to monitor. So
Yes.
it's up to you. It's your own problem how to monitor, or general approach.
So this is a general approach, which I find really helpful, because I found that if you have, the more data about your system you have, the more knowledge you have about how to optimize it, or which parts are subpar compared to each other, or which parts are just not functioning well, right? So if you can have say user creation going on for every 5 seconds or something like that, then you can be sure that user creation works all the time, right?
And is there some good framework that helps you to keep track of things to monitor?
So yes, there are examples in the next slide. Yep. So examples of monitoring solutions out there are Nagios, Zabbix, and Go/Forza. Go is a framework-ish. We wrote in Node.js back in the day, which just accepts new line delimited JSON for its metrics. So pretty much every language out there can send new line delimited JSON these days. It's harder than C than JavaScript, of course, but pretty much everything can do that these days. And then Nagios, which we all love to hate, and Zabbix, which is less popular than Nagios, which we also hate. Anyway, so before I finish, you can probably notice that I haven't mentioned code deployment at all on this talk. And because why I did that is because I think that sending code to servers is a very much solved solution. There are tons of things that do that these days. But these days we actually see lots of companies deploying stuff, right? But when the time of the try comes, what was the last time when an AWS outage happened? Like probably, I don't know, 2 months ago, right? And the whole AWS region went down, right? Because a truck hit it or whatever. It happens actually surprisingly often, and most of the companies are just in one AWS region. And you can, at those times, you can see which companies actually have figured it out, which companies are in this one single AWS region, which just got hit by a truck and they're all down, and there's no saving them. So I very much think that putting code on servers is a solved solution. But I think that keeping code up on servers isn't a solved solution, because there's so much stuff that we still need to figure out. There's so much stuff which isn't really implemented well. So like failovers between data centers these days it's pretty much limited to like giants. I mean, if you have your own hobby project, you won't really invest in that, right? But these days, like even the fact that your application was up while the other company's application was down at the time can actually be a real great market value. It can be like, wow, I can actually use that application while a truck hits their data center or stuff like that, right? So keeping stuff up is my real concern. Putting stuff up on servers can be done with SDP or rsync or really simple solutions like that. So to sum it up, don't upgrade your servers, because you're risking that your current deployment and things which depend on this will break. Just ever so calmly roll that out, grab a new server to do that, roll it out, test it out, verify that it works, run your integration suites on that, whatever, just make sure that it works, then roll it out to production. Maybe you'll even, like if your solution is fancy, maybe you'll ever even be able to, say, roll out half of your production traffic to your new application. This is completely cool. I mean, you get to test your application with real production traffic, right? But still, you know, keep backups and stuff like that. Don't just throw all the new traffic at your new host, or even worse, don't bring your old host down to start a new host, because that's completely silly. The next thing, use the service registry. So don't just hard-code IPs, don't hard-code domains, don't use A records for all your hosting, because at some point you'll miss one single thing, and that one single thing will cause like maybe 1/10 of your requests to fail, and then you'll be sitting there wondering why 1/10 of your requests failed. And instead, just use an automated thing which all your applications talk to, and which knows where all the hosts are located, and which basically knows it all, and can redirect other hosts to right places. Next thing, use microservices. So don't deploy monoliths. Monoliths are more likely to fail. Monoliths are harder to maintain and basically worse. I'm sorry. I know that there are tons of monoliths code bases out there, but I really think that microservices are actually the solution to that. Seeing how Unix philosophy has worked for a bunch of time, like 30 years now or something, I think that single concern is a good way to go. And monitor your servers. Basically know when you're failing, because it's really important to know that, and it's really important to recover in time if you know that you're doing that. Yeah, so this is it. Yeah, thank you.